In module 1 we have a question called disk driver components, and then they've listed out a few few components that we need to name. For example, platter, spindle, read write head, actuator arm, assembly, drive controller board, physical disk structure. So what you have to do is you have to explain the components. For that, knowing the components and the drawing is important. So what you have is you have a disk diagram over here, and then you have like multiple draw a cylindric this thing, and then you have each line of this straight line is called a platter. The circular part is called a spindle, and then you have to have a like in pinball you have these opening stuff, right? So draw like that one needle, that is called an actuator. Okay, so what you have to do is your data is transferred between the disk controller and magnetic platters through read write head, which is attached to through the arm. Okay, so this is the actuator and the arm, and it is attached through this, and then you have to write the data over there. So what happens is you have a controller board, HDA, then you have a power connector and interface. So that's your disk driver components. So what is a platter? A platter is a collection of flat disks. Flat circular disks are called as platters. These data recorded in these platters are in binary code. Okay, they're either in zeros or ones, and then the set of rotating platters is sealed in a case called the head disk assembly. So HDA. The platter is rigid round disk which is coated with a magnetic material on both top and the bottom, and it is polarized. And the number of platters in a storage capacity of each platter determines the total capacity of the drive. You have a spindle holding all the platters together. Okay, you have a spindle. The spindle is connects all the platters, and it is connected to a motor. Okay, so this is connected to a motor so that all of this can spin. So this spin around for a revolutions per minute. That's their RPM. So the common spindle speed is 5,400 RPM, or 7,200 RPM, or 10,000 RPM, and 15,000 RPM. These are your standard speeds. So the speed of platter is increased with improvements in technology. You're making it lighter and you're making it faster. So you have your read write head. Read write head as shown. Here what happens is it reads and writes from the platter. The drivers have two read write head per platter. And then the read write head changes the magnetic polarization on the surface of the platter when it is writing the data. While reading the data, the head detects the magnetic polarization from the surface of the platter and then reads the data. So your read write senses your magnetic polarization and never touches the surface of the platter. So it is always spinning above. And the spindle is when the spindle is rotating, there is a microscopic air gap between read write header and the platters. This is known as head flying height. This air gap is removed when the spindle stops rotating, and then the read write header rests on a special area on the platter near the spindle. So you've seen on all of these olden movies where they use a music player, where they keep a disc and it starts rotating and they place a needle kind of thing which starts reading, right? So what happens over that? It's similar to your read write function. Uh, okay, so and when you keep the spindle separately, that area is called as the landing zone. So you have your read write header over here, and then it gets read. So you have a space over here, and your when it spins, your read write things get read. The ones holding your read write header is called an actuator arm. So you have to write about a term called head crash. Okay, so what happens is when you accidentally touch the surface of the platter outside the landing zone, uh, you have a head crash. In a head crash, the magnetic coating of the platter is scratched, and then this damages the read write, and then you can't use your CDs, right? So that is what is happening here. You have your actuator arm assembly. You have an actuator arm assembly. This positions your read-write head at the location on the platter where the data needs to be written or read. So it holds all your read-write functions, right? So there your heads for all platters on the drive are actually attached to an actuator arm. So this actuator arm assembly and that moves across the platter simultaneously. Like I said, that is your read-write head. Then this your lengthy arm which is holding it is called as your actuator arm assembly. So you have another thing called device controller board. It is a circular. It's a printed circuit board which is mounted on the bottom of a device driver. So what happens is it gives you it consists of microprocessor, internal memory, circuit, and firmware. The firmware controls the power to the spindle motor, and then the speed of the spindle. And then it also manages the communication between your drive and host. In addition to this, you have controls that are read write. So your device controller board is like your motherboard. Okay, so you have all your operations controls over there. Then you have physical disk structure. So in physical disk structure, what happens is you have to draw the same thing. But you have to write cylinder, sector. That is one division is called sector. You have a track. That is like you just imagine a running track. Okay, and then you have a spindle. You have a cylinder. So what happens in your physical structure is the data on the disk is recorded in on tracks, and which is concentric rings on the platter. So these tracks are numbered starting from 0 to the outer edge of the platter. The number of tracks per inch is TPI on the platter, and then and it measures how tightly the tracks are placed on the plate on the platter. Each track is divided into smaller units called sectors. These sectors are individually addressable unit of storage. The data, so the number of sectors per track varies according to the drive type. The first personal computer had 17 sectors per track. The recent disks have much larger number of sectors on a single track. There can be thousands of tracks on a platter, and then depending on the physical dimensions. So what's a sector here is that you're one of this part, only the corner edge, and from here to here, that will be your sector. So you're writing about how you have to format the larger sector of sizes to hold the data, and then you're using in addition to user data, the sector also stores other information such as sector number, head number, or platter number, and then track number. So you have track number, sector number, head number, everything you have to locate the data. And then your cylinder is a set of identical tracks on both surface of each driver platter. And this the location of read write is there referred by the cylinder number and not by the track number. So your tracks on the platter are identified by read write heads that refers to the cylinder number, not to the track number. So learning about disk driver performance, a disk driver is an electromagnetic device that governs all performance of a storage system. So the variation factors will affect the performance. So the variation factors are disk service time. So this is the time taken by a disk to complete an I/O request. Components that contribute to service time on a disk driver and seek time, rotational latency, and data transfer rate. So when you come to disk service time, you have seek time, rotational latency, and then disk transfer time. In seek time, what happens is you have it is described as it's called as access time. It describes the time taken to position the read write header across the platter with a radial movement. So in other words, when you take time to position and settle the arm near the head, okay, so when you're taking the head over, you have this rotational arm, right, to be placed in between. I mean, when your platter is placed in between it, so that it can be read. So the time taken to do that is called as seek time. Okay, so you have full stroke, average, and track to track. Full stroke is when the time taken by the read write head to move across the entire width of the disk from innermost track to outermost track. So innermost to outermost. So the whole thing to complete one whole round, it's called full stroke. Then you have average. The average time taken by the read write head to move from one random track to another, random track, is normally the time taken for 1/3 of the full stroke. It's the 1/3 of the full stroke. Okay, track to track, it is the time taken to move in between adjacent tracks. So back to back, you have concentric circles, right? And then in that, each concentric circle is called a track. So the time taken to move over there is called track to track. So each of these specification is this is done in milliseconds, and it usually takes about 3 to 15 milliseconds. So it has more, the seek time has more impact on the read operations of random tracks rather than adjacent tracks. So random tracks performs more better. So the minimum seek time can be written by the minimum seek time data can be written to only a subset available for cylinders. Okay. Then you have rotational latency. So this is to access the data, the actuator arm moves the read write header over the platter to a particular track, right? So when the platter spins to position the request sector of the read write header, the time taken by the platter to rotate the position to under which the read write header is called rotational latency. This latency depends on the rotational speed of the spindle and is measured in a millisecond. So what is happening here is when the whole platter spins, and then it comes to in this whole sector, it comes to one sector and then stops, right? Your read write header. So the time taken by the platter to rotate and position the data under, so whichever data you need is present in one sector. So to position that to position your read write header to that sector is called rotational latency. This latency depends on the rotational speed of the spindle and is measured in milliseconds. The average rotational latency is one half of the time taken of the full rotation. So you have this calculations which is given, that is your average latency for they've given an example. Okay, so if your average latency is approximately 5.5 millisecond for a 4400 rpm drive, then around 2 milliseconds for 15,000 rpm. So what happens here is you have 15,000, and then you have drive as 0.5 by 250. You get 2 milliseconds. You have data transfer rate. This also, okay, what is data transfer rate is data transfer rate refers to the amount of data which is sent per second using the HBA, that is your host bus adapter. Okay, so what happens is you have to understand that the read write operation to calculate the data transfer rate. If in the read operation, the data first moves from disk platter to read write heads, then it moves from drive's internal buffer. So what happens is when you finally move the data, data moves from the buffer through your interface to the host, then your HBA it moves to the interface, your host interface. So in write operation, what happens is the data moves from HBA to the internal buffer, and then it moves the read write heads. So finally when it moves, it has to move to the platter. So what is happening here is you have an interface, you have buffer, it's called data transfer rate, right? So you have a HBA outside and you have a head disk assembly. So you have an external transfer rate which is measured because you're measuring it outside, and then you have an internal transfer rate that is measured for head disk assembly, and then you have a controller which has your interface and buffer. So your internal transfer rate is the speed at which the data moves from platter surface to the internal bus. So that's your internal transfer rate. And then external transfer rate is when your data moves from the interface to the HBA. The external data rate is generally advertised as the speed of the interface. So you have last one is disk input output controller. Here you have two things, that is queue and disk IO controller. In this we have queue. The location where input output request waits before it's being processed is called queue. And then disk input output controller, it processes the waiting in the queue one by one. Okay, so what happens is your arrival of processes, input output processes, you have a input output controller and which is being processed, so you send it one by one. So based on the fundamental laws, you have average response time is equal to service time divided by 1 minus utilization, where the time taken, utilization reaches 100%. That is, as the input output controller saturates, the response time becomes close to infinity. So until you have a lower percentage of data that has to be covered, you have low queue sizes, and then once it crosses beyond a point, it almost becomes impossible to get, so your response time increases. So you need to explain the graph over there. So this is where the module 1 content ends.